For your Chapter 6 AP questions, yeah, look at me, fancy. We've already done several of these. We did this when we played our game the other day. So I'm going to give you the answers to several that we've already done. So number 1 should be B. So go ahead and answer circle B. Okay, number 2 should be D. Number 3 should be E. Number 4 should be D. And number 5, I don't know if I can move it up. Number 5 should be C. So we did all those in our game the other day. Okay, so in the next page. Yeah, I think we did all of them. So number 6 we have, yeah, we did that one. That was 15, right? So B. And number 7 we have not done. So number 7 says, use the table above to compute the integral of f prime of x from 1 to 3. So we're going to integrate, and we're going to get capital F of x, and we're going to go from 1 to 3. All right, so that's just going to be f of 3 minus f of 1. And these are all capital F's. All right, so it's going to be f of 3 is 2, and f of 1 is 4. So 2 minus 4, so you should get negative 2. So A should be that answer. All right, and then 8, we did not do that one either. So 8 says, using the table, compute g prime of 3. So you have g of x. So if you want the derivative, remember that's the derivative of the integral, which we know whenever you're doing the derivative of an integral, that's your FTC, your fundamental theorem of calculus. So you're going to take your 2x, and you're going to plug it in for t. So you're going to get f of 2x. But then what do we have? Yeah, so times the chain of 2x, so times 2. Okay, so if I wanted to find g prime of 3, g prime of 3 is going to be f of 6 times 2. So f of 6, it says, is 7, so 7 times 2, so it should be 14. All right, and then the next one, we did that one in class. So remember, that's the one where when we wanted capital F prime, we just did our fundamental theorem of calculus, and we plugged in x for the t. And then we did the quotient rule to find capital F double prime. So, and then we plugged in 1, and we got A, negative 3/4. And then number 10, we have not done. So 10 says, use the midpoint Riemann sum to approximate the integral from 1 to 9 of x squared dx using 4 subintervals. So if we're using 4 subintervals, I always kind of draw out the number line. So I say, okay, I'm going from 1 to 9. Yep, and they're going to be with 2. So you're going to have 3, 5, and 7. But then we want the midpoint. So the midpoint is going to be all the ones that are in between. Oops. I don't know what's going on here. So you're going to have 2, 4, 6, and 8. So you need to find f of 2, f of 4, f of 6, f of 8. Okay, so my f of x is x squared. So f of 2 is going to be 2 squared, so 4. So it's going to go up to a height of 4. Then I'm going to have 4 squared, it gives me 16. Then I'm going to have 6 squared is 36. And 8 squared is 64. Now be careful, because when you have these on multiple choice on your AP test, usually it's not all like multiplied out. So see how your answers are? So like 1 plus 9 plus 25 plus 49. 2 times 1 plus 9 plus 25 plus 29. Does this make sense? So if we're doing the midpoint, what's the width of the rectangles? 2, right? So the width is 2. The height of the first one is 4. So I'm going to have 2 times 4 for the first rectangle. The next one's going to be 2 times 16. 2 times 36. 2 times 64. So do you guys see it? C. All right, so then we get to the free response problem. This is going to take us a little bit. Lovely. All right, these free response problems always sound a little bit like nonsense when you read them. I mean, this is kind of ridiculous. Who does calculus when they're talking about naming a baby elephant at a zoo? Apparently we do. Okay, so a zoo sponsored a one-day contest to name a new baby elephant. You know, the baby elephant should probably be named Dumbo. I don't know why this is like a contest at all. What would you guys name a baby elephant? Bobo. Something cute. So apparently there were lots of submissions. So we're about to see exactly how many submissions they had. Okay, so it's a one-day contest. All these people come to the zoo, and they deposit entries into a special box between noon and 8 p.m. The number of entries in the box T hours after noon is modeled by a differentiable function E between 0 and 8, so noon and 8 p.m. Values of E of T, so in hundreds of entries, at various time T are shown in the table above. So A says, use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time 6. So at time 6, that's directly between time 5 and time 7. So if I'm finding the rate in entries, so hundreds of entries per hour, how would I do that? Between 5 and 7. Average what? Average value? No? Average rate of change, right? I'm finding the rate. So what you're finding for the first one, so for A, is E of 7 minus E of 5 all over 7 minus 5. So we get E of 7 is 21, so that's the number of entries in hundreds of entries at time 7 o'clock. Minus E of 5 is 13 divided by 2. So we get 8 over 2, so we get 4. Now what are your correct units? So it would be 4, but it's in hundreds of entries per hour, right? So I would say 400 entries per hour. So at that time, at 6 o'clock, you're getting, pretty close to 400 entries in that per hour during that time. I know this zoo is very popular. There's busloads of children naming this elephant. All right, B. So you would get 1 point for your answer. And usually you get 1 point for the units as well. But in this case, we just get 1 point for the entire thing because it told you the units in the problem. All right, B. It says use a trapezoidal sum with the 4 subintervals given by the table to approximate the value of 1/8 of the integral from 0 to 8 e of t dt. Okay, so I have 1/8. I'm going to integrate from 0 to 8 of e of t dt. Okay, so we're using a trapezoidal sum. So if you need to quickly sketch it out, if you're really visual and you want to sketch it out, that's fine. You can sketch it out. So you had 0, 0, you have 2, 4, you have 5, 13. I mean, just do a rough sketch. You have 7, 21. You have 8, 23. I'm running into different areas here. All right, so your trapezoidal sum ends up being these trapezoids where you connect 2 heights and then you go straight down. The first one is a triangle. Okay, so that's the shape you have. Lovely with my stylus here. All right, so when you come up with your trapezoidal sum, so we're going to do the 1/8 in a second. It's going to be 1/2. H for the first one is 2, so that distance. And then B1 plus B2. So B1 is 0, B2 is 4. And then I'm going to have 1/2, 3, because that's this distance here. And then I'm going to have B1 plus B2. So 4 plus 13. And then I'm going to have 1/2, and I'm going to have 2. And it's going to be 13 plus 21. And then I'm going to have 1/2 and 1, and it's going to be 21 plus 23. Sorry, I've ordered a better stylus, I promise. I'm not going to put up with this all semester. All right, so we come up with the number. Did anybody get this? Anybody calculating for me? So 2 times 4 plus 3 times... if this is right. What'd you guys get? Okay, so it's 85.5. Okay, but I'm going to erase some of this. Oopsie. But some of this isn't actually, we still need the 1/8. So we have 1/8 of 85.5. So 1/8 of 85.5 is 10.688. Or you could have 10.687 if you wanted. Okay, so think about what that is. So it says, using correct units, explain the meaning of this. So what does that 1/8 represent? Why am I doing a 1/8? How is this related? It's 8 hours, so this is related to a formula we learned in class. What's it called?
Average value.
The average value. So this is the average value of the function. Okay, so this is the average. Let me write it down here. So 85.5 divided by 8 equals 10.688 or 10.687 if you truncate, and this is hundreds of entries. So it'd be like around 1069, around there, or 1068.8 hundred, because that we already took care of the hundreds. That incorporated the hundred, so entries.
There's a lot of entries.
This is the average number of entries each hour. Pretty crazy. It's a lot of entries. Okay.
Exciting.
So then part C, it says, at 8 p.m., volunteers began to process the entries. They processed the entries at a rate modeled by the function p, where p of t equals t cubed minus 30t squared plus 298t minus 976, hundreds of entries per hour between 8 and 12. Okay, so they don't start processing the entries until 8 p.m., so after they get the very last one, and they start processing them. Okay, so according to the model, how many entries had not yet been processed by midnight? Okay, so in order to do this, I need to figure out how many they processed during that time, 8 to 12. Okay, so that was the rate that they're processing. So we need to integrate to get the number that they processed. Does that make sense? Okay, so we're going to do, just kind of put that one over there. All right, so we're going to do C, which is we're going to integrate P of T from 8 to 12. And I would just write it out like that. I would not put in the t cubed minus 30t squared, etc., because you're not getting points for writing that. And if you make one tiny mistake, like make a plus instead of a minus, you're missing all the points. So just write it like this. Okay, and then this was a question number 2 problem. So this would be a calculator problem. So 1 and 2 are calculator problems. So you're allowed to use Math 9 in this case. So let's go ahead and do it. So I'm going to hit Math 9, and I'm going to put in my function t cubed. So x to the third minus 30x squared plus 298x minus 976, and my x is going to go from 8 to 12. And it comes out nice. It is 16. Now remember, this is in hundreds of entries. So I'm going to say 1,600 entries. So how many entries have not yet been processed? Kind of tricky. So how many entries did we have at midnight? Or not at midnight, at 8 p.m. How many did we start with? 2,300. How'd you get that, Brian? It's the last value on the table, so it's 2,300 minus 1,600. So there's still 700 entries to process. Yeah. So I'm guessing towards the end of the night, they're starting to get a lot of repeats. So they're starting to slow down. They don't care at that point. Someone has a brilliant name for an elephant. They're just going to go home at midnight. I don't know. All right, and then D. So according to the model from part C, at what time were the entries being processed most quickly?
Probably right over the.
Not integrate.
Wait, is that an acceleration?
No. It's a derivative. Why do I need a derivative?
Because it's the rate of change.
So you have some kind of cubic function, and you're finding the maximum of that cubic function. Does that make sense? You're finding when you have, when your slope is equal to 0, not the biggest. You're finding when your p of t, the number that you're processing, or the rate that you're processing is the fastest. So p of t is a rate. You're finding the maximum rate. But you're finding at what time were the entries being processed most quickly? What time was the rate of change of the entries being processed the highest? I don't know how to say that correctly. So we're doing the derivative of p of t, and we set it equal to 0. So p prime of t, we want to find when it's equal to 0. Okay, so you could just do n deriv, and you could graph the derivative. We haven't talked about that much before. We'll skip that. But let's actually find the derivative, so p prime, and we'll set it equal to 0. So p prime is going to be 3t squared minus 60t plus 298. Now this problem could have been nice to you and made it like 297 or 300, and then you could just pull out a 3 and possibly factor. But 298 is not divisible by 3. So you would have to use quadratic formula here. So you can do that, but since I told you question 2 is a calculator question, what else can you do? Yeah, graph and find what? You're finding when this, no, you're finding when this derivative that we just found is equal to 0. Or you could find the original when you have a maximum, right? So since we did the derivative, let's find the derivative when the derivative is equal to 0.
Test, or would you have to like say graphed equation and found the maximum or something?
You could do that. I'm going to make my x values go out a little bit. Okay, so I have two places where I have a 0. And I'm going to find the 0 on my calculator. So left bound, right bound, guess. So I get t is equal to 9.183, and t is equal to 10.816. Did you guys get that? Okay, so you put those on a number line. Now remember, whenever you draw a number line, you always have to explain this in your problem. I found the zeros of this function. So I put this in for y1. I graphed it. And then I found where it crossed the x-axis.
So wouldn't it just be quicker to graph the original function?
You can, and then find the maximum.
Because then you don't have to do the number line.
That's true, because then you don't. Do you see what I'm saying? So you could also graph the original. But be careful, because the convenience of having the number line is because you're only from 8 to 12, right? You're only processing until midnight. This is a trick question. It almost got me in the first class. All right, so I'm putting these on this number line. So I'm putting my, you could store it as A, you could store this one as B if you want. You put those on a number line, and you'll see that it's decreasing. No, wait, it's increasing. What do you think? Yeah, because f prime is positive. So it goes up, down, up, like that. So your maximum would be at 9.183, right? It's an x cubed function. It makes sense that it would be at this one. However, you're on a closed interval. And we know that when we're on closed intervals, you also have to check the endpoints. So would the left endpoint or right endpoint also be a maximum? The right. So over here, because it's an endpoint. Right? So you need to compare the two values. So what the AP test will typically do is they'll do like a little chart. I keep just like moving things up. There we go. All right. So they'll do like a little chart. Oops, I don't know why I'm doing part E here. And they'll compare these different values. So they'll have T, 8, and 12. They put the endpoints on, and then they do 9.183, and they do 10.816, and then they plug those into the original. which of course I deleted my original from here. Does anybody have those in the Y1 still? So they can plug them into Y1.
I do.
You do?
8 is 124.
Okay.
I have 3x cubed. No, my equation isn't right. That's a derivative.
Okay. So yeah, so I plugged them into the original, like the t cubed one.
You get 0. Okay.
What have I got here? I don't know why. So 8 is... I'm getting negative values. Are you guys getting negative values? Maybe I didn't plug it into the original.
Negative values doesn't seem right.
It should be plus. I have the wrong thing. Here we go. I made a mistake too. Yeah, I do get 0. So I get 0 for 8.
0, 5.
5.088 or 89. 2.9113 and then 8. So which one is a maximum?
8. That's
Yeah.
12.
So at 12. Okay, so if you look up here at the scoring, I don't know if you guys can see this. It's on your sheet as well, but it says for that last problem, you get 1 point for identifying where p prime of t is equal to 0. So you get 1 point for that. You get 1 point for identifying candidates. That means, so saying the max could occur at that 9 one, or it could occur at 12, the endpoint. And then you get 1 point for your answer with justification. So you would need to say something like, P of 12 is equal to 8, and P of 9.183 is equal to 5.88. Therefore, you'd also probably need to talk about how it goes up, down, up as well. How you have P prime. So P prime is greater than 0 on 8 to 9.183. And P prime is less than 0 on, and you'd have to write out what we had on that tape in the chart, you know, because you could never just use the chart, you always have to write it out. So you need to write out all of that, and then say, therefore, there is a maximum at t equals 12, so at midnight. So at midnight, they were processing the most. So that's kind of a trick question. You would think that it would be that maximum that we had before, the 9.183, but it was not. Trick.
You restate what we're supposed to say, therefore.
Yeah, so you need to say, like, everything that's in this chart. So you need to say P prime is greater than 0 on 8 to 9.183. P prime is less than 0 on 9.183 to 10.816. P prime is greater than 0 on, you know, so you need to say all the places where it's positive, negative, positive, negative. Now you have to be really careful, though, because you could say P, right, the original function P is increasing on that interval, or you can say P prime is positive, but do not mix them together and say P prime is increasing, because that would be talking about the second derivative. Does this make sense? They're very picky when it comes to grading. You need to say it very precisely.
I thought P prime is
Okay, so on this one it says the function g is defined and differentiable on the closed interval -7 to 5, and it satisfies g of 0 equals 5. Okay, we call that an initial value, because this is our graph of g prime, and I'm giving you the initial value for g of 0. So it's antiderivative. That helps you find like the plus c a lot of times. So it says the graph of y equals g prime of x, or the derivative of g, consists of semicircles and 3 line segments as shown in the figure above. Find g of 3 and g of -2. Okay, so if I want g of 3, I want to somehow use this initial value that's right here, this g of 0 equals 5. So what I'm going to do for part A is I'm going to integrate from 0 to 3 of g prime in order to get g of 3 minus g of 0. That's the fundamental theorem of calculus, correct? I integrate g prime to get g. But what the integral of g prime is it's the area on this graph from 0 to 3. So I look at 0 to 3, and I have a quarter of the circle and a little triangle. So I find the areas of both of those. So the quarter of the circle is 1/4 pi r squared. So it's going to be 1/4 of pi times, what's r in this case? Oops. Yeah, so 2 squared. Yep. Plus, the next one is a triangle, so it's 1/2 base. So the base is 1 and the height is 3. So it's 1/4 of 4 pi, so it's pi plus 3/2. All of that is equal to g of 3, which we're trying to find, minus g of 0, which is 5. So g of 3 is then pi plus 3/2 plus 5. So it's going to be, if I add 5, I'm really adding 10/2. So it's going to be 13/2. No, because you'd add the 5 to the other side.
Oh, no, I see.
Wait, I'm confused why that's G of 3. G of 3 is the, are you taking the antiderivative of G prime?
The antiderivative gives you g of x, and it's going to be
Okay.
g of x evaluated from 0 to 3. Okay, so it's pi plus 13/2. You could find a decimal approximation if you want to, but this is a question 5, so this would be a non-calculator one. So they'd probably want that answer. So you'd get 1 point for using g of 0 equals 5. You'd get 1 point for finding this answer of pi plus 13/2. And you'd get 1 point for finding g of -2. So how about you guys go ahead and try to find g of -2. So I'll pause. Okay, so part B. Or not B, still part A, right? So you're going to have g of -2. And I don't care how you write it. You can write it 0 on the bottom to -2 if you want. But usually we would have, we would use 0 to -2 like that of g prime. So it would be g of -2 minus g of 0. So if I wanted g of -2, do you see you just take the integral from 0 to -2? Or what am I doing? -2 to 0 after I just said that we wouldn't write it like that. You could write it that way, I guess. It's just kind of weird. So -2 to 0. So it'd be g of -2. G of 0. Good Lord. G of 0 minus g of -2. All right, so g of -2 then would be g of 0, and then you'd subtract out the integral from -2 to 0. Do you guys see what I'm doing? So you could just find this part first if you want. Okay, so if I integrate from -2 to 0, what it represents on your graph is the area from -2 to 0, so it'd be this part, which we said was 1/4 of the circle, which was just pi then. The area was pi. Do you guys have that? So you'd have pi equals g of 0 was 5, so 5 minus g of -2. So you're going to get g of -2 equals 5 minus pi. Do you guys get that? Yeah, so that's your answer. So you'd get 1 point for your g of 3, you'd get 1 point for the g of -2. You get 1 point for using g of 0 equals 5. Put all these up. All right, and then B. So let's find the x-coordinate of each point of inflection of the graph, y equals g of x on the interval -7 to 5. Explain your reasoning. Hey.
I've got an engineer here, so everybody acts smart.
Okay. They are very smart. All right, so you're finding the x-coordinate of each point of inflection. So a point of inflection for the graph of g would be involving g double prime, right? The second derivative. So you guys have the graph of g prime. Okay, so if you have the graph of g prime, you're looking for what to find g double prime?
The slope of that is 0.
The slope equals 0, right? So when we look at this, what else could the slope equal? Not just 0.
Undefined.
Undefined. Okay, so there are places where the slope is equal to 0. Is it what?
Or undefined, would it be like a plus?
It would be, yep. So you're going to have right here, that's where your slope is equal to 0. You guys see the point I just drew? So at x equals 0. And then there are places where your slope is undefined too. Several places. Right here, right here, right here. So corners and cusps. Yeah, and it did say on -7 to 5, but it doesn't include those endpoints. So we don't really need them. All right, so let's do our little number line. And remember, when we draw the number line, you actually have to write out what's being said on the number line. But we'll go ahead and draw it because it helps us with our G double prime. So we have, what is that, -2, 0, 2, and 3. So we'll put those on there. So -2, 0, 2, 3. Okay, and we're talking about G double prime. So is G double prime positive or negative on each of those intervals? So the slope of G prime was positive until you got to that first corner. So it was positive because it was going up, right? And then it was still positive. And then at 0, it all of a sudden went down. Do you guys know what I'm saying from your picture? And then the slope was positive. And then after 3, it was negative. So points of inflection only occur when your second derivative changes from positive to negative, or negative to positive. So it has to actually change in sign. Okay, so it's going to occur at 0, at 2, and at 3. And then you'd have to explain your reasoning. So again, once you have that chart drawn, I mean, the chart is incredibly useful, right? You can tell just from the chart where your points of inflection are, but you need to write out what's happening in the chart. So you would say G double prime is positive on each of those intervals, and you list out the 3 intervals where it's positive, and say G double prime is negative on 0 to 2 and 3 to 7, or 3 to 5, I guess. So you'd have to write all that out, and then you could say, therefore there are points of inflection at 0, 2, and 3. Another way you could say it is you could just say, points of inflection exist at 0, 2, and 3 because G double prime changes sign, and that would be enough. So when you talk about G double prime, like points of inflection, you can just say changes sign. Why could you not do that for like a max or min, though, and say changes sign? Yeah, you would need to know which one it was, like a maximum or minimum. So you would need to know that it went from positive to negative to be a maximum, or negative to positive to be a minimum. Does that make sense? So you can't just say changes sign. All right, so you get 1 point for identifying your possibilities, 0, 2, and 3, and 1 point for explaining why those are points of inflection. And then the last part, it says the function h is defined by h of x equals g of x minus 1/2 of x squared. They always do this, where they have you do this whole problem for g of x, and then all of a sudden they introduce a new function that involves g of x. So it says find the x-coordinate of each critical point of h, where x is between -7 and 5. So critical points are when your first derivative is equal to 0 or undefined. So we're going to do that. I'm going to give myself some room here. Okay. So I'm going to have h prime of x is going to be g prime of x minus the derivative of 1/2 of x squared. So you've been so used to doing integrals at this point, right? So it's just x. So you want to find when it's equal to 0 or when it's undefined. So let's start with 0. So you're finding when g prime of x is equal to x. So let's look back at our picture. G prime of x is equal to x. So G prime is what we have. That's the y value of our graph. So there's 1 point in particular that you can see right away where G prime is equal to the x value. Do you see it? 3, 3. Did you guys see it? It's right here. 3, 3. Would there have to be another place where they're equal, where the x and y values of this graph are equal to each other? So if you look at it on the left side here, these are all points that are negative for the x and negative for the y, but it's looking like they're never going to be equal to each other, right? Do you see? It's not like on the line y equals x. Does there have to be another point that's on the line y equals x? There is one. Where would it have to be? It's on the semicircle, yeah. Did you guys see it? So it's a little confusing. It's hard to draw. So it's right. It's where you're on the line y equals x, and you're on this semicircle, which that would be like y equals, or it'd be x squared plus y squared equals r squared, so 4. So if you replace y equals x, you'd have x squared plus x squared equals 4. So 2x squared equals 4. So x squared equals 2. So x equals square root of 2, or negative square root of 2. But in this case, it's positive, right? Based on the picture, like where I drew it. So you get 1 point for identifying, or for finding h prime. So we did that. We found h prime was g prime minus x. You get 1 point for identifying that it'd be square root of 2 and the point 3, 3. 1 point for your answer of square root of 2 with all the work, and 1 point for the answer of 3 with analysis. So we didn't actually write out x equals 3 as well.
Can I have a question? Wouldn't, no, so I was thinking x, or square root of 2, square root of 2, like negative square root of 2, but then I got.
Yeah, that's not really on that line, right? So that other slope is just really shallow, so it wasn't giving it to you. So that's all the places where you have critical points. And then you would need to classify each as a local, like a relative min, a relative max, or neither, and then explain your reasoning. So that's when the chart comes in handy again. So if you talk about h prime, you want to know when h prime is positive, negative, so on. So you're going to have square root of 2 and 3, and then your endpoints, which are open at negative 7 and 5. And then you just have to try numbers. Like if you try 1 into h prime. So h prime we said was g prime of x minus x. This stylus is awful. Okay, so if you look at your picture, what's g prime of 1? Kind of hard to see, isn't it? I don't know.
1.7.
Yeah, so it's into that equation x squared plus y squared equals 4, right? So you would have 4 minus 1, so it's square root of 3. So it'd be square root of 3. 1.73. Yeah. So that's somewhere around here. It was 1 comma square root of 3. All right, and then if you have minus x, so square root of 3 minus 1 is still positive. So this is positive. Then if you try something bigger than square root of 2, like 2, if you plug in 2, you get 0 minus 2, that's negative. And if you plug in like 4, right, 3, 4, 4 looks like it's smaller. It's like around 1/2 maybe, or 1. Looks like maybe 1. So 1 minus 4, that's negative. So it'd be going up, down, down. So it looks like the maximum would occur at square root of 2. And then you would need to write out why that is true. You always need to explain the table. And then neither at 3. All right.